Welcome back to another lesson. In this video, we are going to look at a question that was tested in December 2022, and we are looking at question number 4. The question reads, the production manager of Medsex Limited, a manufacturer of machines, is investigating a claim by customer about machine A and machine B that it manufactures. The claim is that machine A has a longer useful life than machine B. A sample of 60 machines A were taken from the market and revealed that machine A has a meaningful life of 28,000 hours with a standard deviation of 900 hours. A sample of 80 machines B has a mean useful life of 30,000 hours with a standard deviation of 1,000 hours. You are required to advise the manager if there is any significant difference in the useful lives of the machines and use a significant level of 5%. Good. How do you solve this question? And it has 8 marks. The first thing here is that this is a hypothetical testing question. This question was testing on hypothesis. We are saying that in this question is testing on hypothesis. It is a hypothesis testing question. Hypothesis testing question. And since you remember here, we are using the means. The means, you're told that one has a useful mean of 28,000 and the other one has a useful means of 30. We are testing whether they have any significant difference in their means. So it is a case of two means, and it is the case of means difference. So here we are saying that this is a hypothetical testing question, and it is a two-case sample. Is a case of two samples and checking all specifically interested or in the area of means difference. Means difference. We want to see, is there any significant difference in their useful life? Now, what you need to do here is to formulate your hypothesis. Once you formulate your hypothesis, you move ahead and you substitute in your formula. You see, the good things with the accounting and maths is that we normally work out with formulas. Once you have mastered that formula, the rest becomes easy. So let's formulate our hypothesis. The first one, we are assuming that the means are the same. There is no difference. So we say that H naught, in this case, H bar should be equals to H bar 2. In this case, we are assuming that they have no difference. That means 28,000 should be the same as 30,000. That is the first. The second one, we assume that 28,000 is less. We see which one is going to give us. So HA, in this case, we are assuming the mean of the first one, 28,000 is less than, that is 28,000 is less than 30,000. Now, this one, and you have already been told that the significance level is at 5%. In other words, you are told that the alpha is 0.05, the significant level. So how do we go about this? We have to conduct what we call t-static, or we test static. Test static, there is a formula which says that t is equals to x bar 1 minus x bar 2 divided by the square root of n1 minus 1 standard deviation squared plus n2 minus 1 standard deviation squared, the whole of this divided by n1 plus n2 minus 2, and then you multiply this one by 1 over n1 plus 1 over n2. So I had mentioned there before, you only need to understand this formula so that you can get your test statistics. So in this case, our mean 1 is 28,000 minus our mean 2 is 30,000 divided by the square root. How many samples were taken for the first one? Let's go back to the question. You are told that they tested 60 machines A and 80 machines B. So N1 is 60. So this one will be 60 minus 1. The standard deviation of machine A is 900 hours squared plus 80 minus 1. Standard deviation there is 1000 squared divided by 60 plus 80 minus 2, and then multiply the whole of these by 1 over 60 plus 1 over 80. So here, when you have this, you have what we call T calculated. T calculated. T calculated, you're going to find that is negative 0.07. So what do you need here? What you need here is to understand this formula. Once you understand this formula, you come and substitute to get your T calculated. We are going to compare this T calculated with the T critical. Now, when you go to your standardized table here, we shall have our table here. Here we have our table here. Sorry, this is not there. Let me draw a nice table. We draw a nice table here. We want to look at T critical. Let's look at T critical and compare this with the T calculated. Now we are going to reject if, remember, we are told that our significance, level of significance is this. You have already been told here that use a significant level of 5%. Therefore, we are only going to reject 0.05. Reject the hypothesis. Reject H naught at 0.05 and accept the remaining one. This part here will be accept. You accept here. Accept at 95%, which is the same as 0.95. Now, this T critical is read from the table. It's read from the table here. Yeah, when you use your table, you'll find that the T critical is negative 1.6973. Now compare these two. T critical is negative 1.6973 and T calculated is negative 0.07. From your knowledge of algebra, which one is bigger? What is between negative 10 and negative 1? Which one is bigger? Of course, negative 1 is bigger. The more you go closer to 0, the bigger the value. The more you move away from 0 on your number line, it means that negative 1.6 is smaller compared to negative 0.07. So, what can we say here? Conclusion. Conclusion. You say accept null hypothesis. Accept null hypothesis since T calculated is greater than T critical, is greater than T critical. So meaning, in this case, what it means is that it therefore means there is no significant difference. There is no significant difference between those two machines. There is no difference in the useful life. In the useful life of the machines. That is what this means. So in this question, the key area that a student needed to know is how to find the T calculated, because once you get the T critical is read from your tables. So having reached at this point where you are looking at this is machine, where you are looking at the questions, it means you know how to read your tables. You are waiting to sit for your exams. Now, I think you are done with that part. We move on to the next part here. But that's how many marks were those? Oh, it was 8 marks. So you have successfully gotten your 8 marks there. We move on. The next part, you're told that the following data relates to the number of computers sold each day over the last 240 working days by a leading firm. Now, you are required to determine the model number of computers sold. Mode. Here, similarly, here you also need to just get to know how to find the mode. Get to know how the formula. How do you find the mode? Lower class limit plus D1 divided by D1 plus D2 multiplied by the class width. Once you get this and identify your model class, the model class refers to the class with the highest frequency. So in this case, the class with the highest frequency is 50. Once I identify the class with the highest frequency, this is my class with the highest frequency. This one here is my class with the highest frequency. There are 3 at the bottom and 4 at the bottom and 3 on top. Now we want to find the mode, because here it is between 30 to 35. We need to get the exact number. What is the lower class limit here? The lower class limit here is 30. 30 plus D1 is normally the frequency minus the frequency before. Divided by D1, the same, frequency minus frequency before, plus frequency minus frequency after, multiplied by the class width. What is the class width? That 5 and 30 is 5. So we end up with 30, 30 plus 50 minus 42, that is 8, divided by 8 plus 5 times 5. This is 30 plus 8 divided by 13 times 5. What do you get here? Let me take my calculator here. Take my calculator here and find I find 8 divided by 13 times 5. This is 8 divided by 13 is equals to 0.61, then times 5. That gives me 3.0 plus that. So my mode here becomes 33. This is 33.08. 33.08. I hope it's clear how to find the mode. Now the second part here is to find the quartile deviation. The quartile deviation is also called semi-interquartile range. Here, quartile deviation is also called semi-interquartile range. These terms means the same, interquartile range. It only means that you get the Q3 minus Q1 divided by 2. So we need to look what is Q3, what is Q1, and then now to find my quartiles, I will introduce something here we called cumulative frequency. I add this one, 12 plus 18, 30 plus 35, this give me 65 plus 42, this give me 107, this give me 157 plus 45, that is 202. Yeah, no, not 202, is 202 here. This is 202. 157 plus 45, that is 202. Then I add this, I get 232. I add this, I get 240. Correct. Now, what you do, if you want to find the lower quartile, just take 240 divided by 4. It will help you to get Q1. So, let me now find my Q1 first. Q1 is given as L plus 1 over 4n minus Cf divided by F times I, the class width. So I have already found my class belong at 60. So I come to cumulative frequency. Where 60 is? 60 is here. What is the lower class limit here? The lower class limit in this class is 20. So I come here and put my 20. I'll come here and put my 20 plus 60 minus cumulative frequency before. Come to the table. Cumulative frequency before my Q, that is 30. And then I also need to know the frequency of that class. Cumulative frequency before is 30, and then the frequency of that class is 35. So cumulative frequency before is 30. The frequency of that class is 35, and the class width. I go back and check the class width. What is the class width? Class width is 5. Class width is 5. So here I will have 20 plus 30 divided by that 5 times 5. What do I get here? 30 divided by 35, then times 5. Get 4 point plus 20. This give me 24.29. Then I need to look for Q1. Now I've already looked for Q1. I need to look for Q3 now. We are already done with Q1. We need to look for Q3. That quartile is given as L plus 3 over 4n minus Cf divided by F times I. 3 over 4 times 240. 3 divided by 4 times 240 give me 180. I need to go to check in my cumulative frequency where my 180 is. Come here, my 180 belong to this class. Yeah, my 180 belong to this class. So the lower class limit there is 35. So my lower class limit here is 35. That 5 plus 180 minus cumulative frequency before. Cumulative frequency before my class is 157, and the frequency of that class is 45. 157, and then this is 45 times 5. I hope that is clear. This is times 5. 157 is the cumulative frequency before my that quartile here, 157, and the 45 the frequency of that class, and the class limit here is 35 and 30. This gives me the class limits here is 35 and 40 give me 5, the class width. Now let's work out here. We shall have what this implies: 35 plus what is 180 minus this one minus 157, get 23. 23 divide by 45, then times 5. This is 2.6. This is 2.6. Add to that 5 plus that 5. This give me that 7. That 7.6. So how do I get my quartile deviation? Quartile deviation. Quartile deviation, I'm going to find that is 7.6 minus what was Q1. Q1 is 24.29. That's 7.6 minus Q1 is 24. Let me go on top a bit. 24.29. This is 24.29. 24.29 divided by 2. And what is the answer? This is 37.6 minus 24.29 divided by 2. This gives me 6.655. Good. Up that point, I hope it's clear. The next we are supposed to look for is you get the coefficient. Get the coefficient, the quartile coefficient of skewness. Here we are supposed to look for quartile coefficient of skewness. Similarly, here we only need to know which formula we're going to use. The formula for this quartile coefficient of skewness is Q3 plus Q2, Q3 plus Q1, minus 2Q2 divided by Q3 minus Q1. What are we missing here? We have already calculated Q3 and we have already calculated Q1. What are we missing? We are missing Q2. So I will come and find Q2. Q2 is the median, which is L plus a half N minus CFB divided by frequency times I. 240, it means that the median will be at 120. Of course, that is 240 divided by 2. Come here, let's check where 120 is. 120 belong to the same class here as the mode. So 157. We see this 157 carries from 108 to 157. So 157, here we have 120. So our lower class limit here is 20. Is 30. Yeah, 30 plus 120 minus, what is the cumulative frequency before? Let's go back to the table. Yeah, that is 30. Cumulative is 107 and the frequency of that class is 50. I hope you can see 107 and 50. So we come here and get 107 and 50 multiplied by 5. What do we get? Let me go to my calculator here. I find this is 120 minus 107 is 13 divided by 50 and then multiply by 5. This is 1.3. So 30 plus 1.3 and Q3 is 31.3. Good. Having obtained this, the next is just to bring your answer into the formula. What is Q3? Q3 we calculated on top here. Q3 we calculated here and we found that Q3 was 37.6. So we have 37.6 plus 37.6 plus Q1. Q1 was 24.29 minus 2 times that 1.3. It is 2Q divided by Q3 minus Q1. That is 7.6 minus 24.29. Let's do our maths. Here we have that 7.6 plus 24.29, then minus that is minus what? 2 times that 1.6, that is 61 0.60, sorry, this should be, that is 662, that should be 62.6. That 1.3 times 2, that is 62.6. Is that all right? Yes, you get negative 0.71. So here we have negative 0.71 divided by that 7.6. This is that 7.6 minus 24.29. 13 point, you are dividing this one by 13.31. What is the answer? What is the answer here? We shall have negative 0.71 divided by 13.31. That is negative 0.05. So they are negatively skewed. They are negatively skewed, and of course negative 0.05 means that it is not it is closer to 0, of course, but basically you're supposed to interpret here. You're supposed to say that the coefficient of skewness is negatively skewed. Here you say this negatively skewed. Anyway, that's how you are supposed to get your 20 marks. 20 marks was supposed to be obtained. It's such an easy step. I hope you have understood the concept. Looking forward to meet you in another video. Goodbye.